1 minute of team talk, and you need to compare which shapes you put in which columns with your teammates. You got 1 minute. Go. Okay, first of all, a little warning. In geometry, we prove things. We say things to be true based on evidence. This was a special activity. There's actually not a lot of evidence in these images. In other words, if we wanted to say that a shape had 3 congruent sides, then we would need tick marks showing that those 3 sides were congruent. So this was a special activity trying to get you to think about what things look like. But after this activity, we only use evidence that's in the picture. So for example, later on, if there are no tick marks, then you do not say that those sides are congruent. But during this activity, you could say that they're congruent if you think they are. Okay? Now, look at your new desk and look at the label and make sure you know what team you're on and what number you are. So now I'm going to go by team because you just added team talk, and let's see how we did. Team B. What did you think were all acute? Ziumara, what did you think were all acute?
E, C, G, H, J.
Did your whole team agree on that? C, E, G, H, and J. Now, don't mark yours wrong if you missed one. It's not really a matter of right and wrong today. It's a matter of trying to get an idea of what's going on. Team F. Team F. Stephanie, what did your team put for 1 right angle? I'm sorry? Did your whole team agree on that? You did? Okay. A and F. Very good. And Team A. What did you put for 1 obtuse angle? Eric?
D, B, and I.
Did the whole team agree?
Yes.
You did? B, D, and I. Very good. And Team E. Kalasia, what did your team think for 3 congruent sides?
C, E, H.
Did your whole team agree? C, E, and H. Very good. So a couple things you'll notice is that C, E, and H showed up in 2 columns. All acute and the 3 congruent sides. Interesting. I wonder what that means. Maybe we'll learn about that. Any comments or questions on the warm-up activity? So this is going to lead us into our exploration of triangles, which begins today and will continue for several weeks. We have a lot to cover. Hopefully you already titled your lesson, Lesson 4.1. You don't have to write the words of the title of the lesson, but you need to read it so you know what we're going to be studying today. And I know this is tiny here, but you can read the goals, or they'll be presented to you right here. The goals for today are to be able to find the measures of interior and exterior angles and to apply theorems about interior and exterior angles, which leads me to my first instruction. please take out your cheat sheet. Have it sitting somewhere next to your paper so that you can refer to it when necessary. And remember that I am providing you with a cheat sheet because I'm trying to eliminate the amount of time that's required for writing these things down because time is so valuable in school, in class. But you have to know these things. So, some vocabulary that you will be introduced to today as well. The idea of an auxiliary line, a corollary, interior and exterior, an interior angle and exterior angle. All of these terms will be utilized today. Are there any questions so far? So let's jump in and start learning about triangles. Now, I've said this to you before and I'm going to say it again. There are things that you should be writing down and there's things that you don't necessarily need to write down. How do you know? Well, if it's something that I really am emphasizing, I might highlight it or underline it or circle it. That's a clue. Or you just make the judgment for yourself. You're a mature young person. You're in a 10th grade class. You decide for yourself. Do you really need to write down what an equilateral triangle is? I would hope that you don't, because you should already know what an equilateral triangle is. In fact, I would expect that you know all three of these. However, spelling counts, so you might need to write something down. So, there are two classification systems for triangles. By their sides and by their angles. Here are the names by side. Scalene, isosceles, equilateral. Scalene, none of the sides are congruent. Isosceles, two of the sides are congruent. Equilateral, all the sides are congruent. Notice the tick marks. That is showing us that they're congruent. We're not guessing, we're not assuming, we're basing it on evidence. Any questions about that? Now, the system for classifying by angle. I would say there's one new one, the rest of them you should already know. An acute triangle is a triangle that has three acute angles. A right triangle has one right angle, and an obtuse triangle has one obtuse angle. An equiangular triangle has three congruent angles. So I would say that might be something new for us, because that's not usually in a 6th grade or 7th grade curriculum, the idea of equiangular. So you have to be able to distinguish between the different classification systems. One is by the sides, and one is by angles. And you have to know the terms that apply to each one. Are there any questions so far? So far, I am laying foundation. I am giving you ideas that are going to be utilized for more complex explorations. Are there any questions so far? So again, I want to be clear. You have to know all of these terms. Okay? So now some new material. The idea of interior and exterior. Not that hard to figure out, but the interior is inside the shape, exterior is outside the shape. And when we talk about angles, we're talking about interior angles. They're the angles inside the shape. And an exterior angle is formed when you extend one of the sides of the shape out beyond the vertex, and you get what's called an exterior angle. That's going to be important in a little while. Any questions about that? You are also going to start seeing something called an auxiliary line. And you're not going to see the term auxiliary line. You're just going to see the line. You just have to know what it is. It's a line that's added to a picture. So it might be added by you. And when you add an auxiliary line, what it does is it actually allows us to prove some things that you couldn't without it. For example, let me get rid of the auxiliary line for a moment. So now it's just a triangle with three angles, 1, 2, 3. But when I add the auxiliary line, all of a sudden we've got two more angles labeled. And now watch this. Watch what happens when I take out this and this. An auxiliary line, if you draw it correctly, is parallel to part of the figure. So what could we now say about angles 1 and 4? What could you now say about them? Think about it for a moment. Good, we got some light bulbs. John? They're congruent. Why? You are absolutely correct. You said that beautifully. Alternate interior angles. Those are congruent. Beautifully said. Had we not drawn the auxiliary line, we would not have been able to say that because we wouldn't have been able to see it. Excuse me, I apologize. We wouldn't have been able to see it. Okay? So an auxiliary line allows us to do things that we couldn't without it. Any questions about that? Okay? And so now to the theorems that we're going to be using today. So you have your cheat sheet, so you don't have to copy anything, but now we need to talk about what the theorems say and what they help us to do. I referred to the triangle sum theorem, I think, when I handed you the cheat sheet. You've known the triangle sum theorem probably for 2 or 3 years already. You just didn't know it was called the triangle sum theorem. You just knew that the angles of a triangle always add up to 180. But now you're seeing it in its real form, the theorem. So the triangle sum theorem will be used a lot. We also have some new things. So again, that was something you already knew. What about the exterior angle theorem? You're going to actually have to prove this theorem as part of your homework assignment. The exterior angles theorem says that this angle here, formed by extending the bottom line, the bottom side, will equal the sum of that angle and that angle. So let me move this up a little bit. So the measure of angle 1 equals the measure of angle A plus the measure of angle B. So you have one proof to do as part of your homework. You're going to have to prove that. And it's not easy, but it actually is five statements, I believe. And we're also going to use this theorem to solve some problems. Any questions about that? All right. And so you are finally going to be introduced to a new term, a corollary. You can think of a corollary as kind of a sub-theorem. It's not its own theorem. It's based on another theorem. And so we call it a corollary. It kind of works together with something else. The corollary to the triangle sum theorem says that if you have a right triangle, so it's based on a right triangle, whereas the triangle sum theorem is for all triangles. So this corollary is a specific case. If you have a right triangle, the acute angles, that angle and that angle, will add up to 90. In other words, they are complementary. Which makes perfect sense, because if all three angles add up to 180, and that one's 90, take away the 90, you're left with 90 degrees. These two must add up to 90 degrees. And that's what it says right there, and that's what the corollary to the triangle sum theorem says. Any questions about that? Okay, the first type of experiences we're going to have involve a little bit of grunt work. So I like to give you a heads up so that the grumble groans are kept to a minimum. It is challenging because of the perseverance that's involved. The math work itself is not that challenging, but there's thought involved and you have to persevere, okay? So let's jump in and talk about classifying triangles. So, of course, write example 1. You don't have to write the actual instructions. Now, we are asked to classify this triangle by its sides. So we need to say scalene, isosceles, or equilateral. But we must have evidence to support it. So there is no guessing. It is not like the warm-up. In other words, if it said this, then you could say that it's isosceles. If it said this, then you could say it's equilateral. But it doesn't say any of those things. That doesn't mean it's scalene, because we have other evidence. We have this, this, and this to help us. And so we have to find evidence and then come to a conclusion. So we have to figure out what type of triangle this is. You have 1 minute to talk with your teammates to try and come up with a way that we could prove whether this is scalene, isosceles, or equilateral. 1 minute team talk, see if you can figure out how to prove it. All right, what'd you come up with? How can we prove this? Nathaniel, Kadir, and then Sharik. What can we do? Okay. Okay, Sharik.
We use the distance formula for PQ and OQ.
Okay, why not PO?
Because we know PO is smaller than the other two sides. There can't be equilateral.
Ah, and you answered my next question, so thank you for being clairvoyant. I appreciate that. We can already eliminate equilateral because you can see there's no way that PO is the same size as the other two. But it seems like it's possible that PQ is equal to OQ, but we need to prove it. So let's go ahead and do that. And these are brilliant ideas that you guys had. So if you were one of the people who figured that out, great. If you didn't, it's no big deal. Now you just need to try to understand how to do this. So what we want is the distance from here to here. Now, unfortunately, this side is not laying on a grid line. If it was laying on a grid line, then it would be really easy. You just count the grid. But it's not. So we need the distance formula. Now, so we're going to do PQ first. Remember, when you're referring to a distance, you write PQ. If you're referring to the object, then you put a line over it. But we're not referring to the object, we're referring to the distance, so it's going to be PQ equals the square root of the difference of the x's plus the difference of the y's squared. So take the x's. 6 minus -1. 6 minus -1, but you guys are my super high level students. We could do that mentally. What's 6 minus -1? What does that come out to? 7. So we could just write a 7, use our mental math abilities. And then do the y's. 3 minus 2, well, that's not hard. Now, mental math. 7 squared, 1 squared is 1, so this is really the square root of 50. Now, we could punch that into our calculator and find the actual distance, but we don't really need to, because we're going to use the distance formula to do this one, and that's going to come out in radical form too, and all we have to do is compare the radical forms, and we'll know whether it's the same or not. Nathaniel, you had a comment?
Can we just simplify it?
You could also simplify it, but you're going to see in a moment why you don't even need to. It's just kind of extra work. So let's now do the distance of O cubed. Same idea, distance formula. Difference of the x's squared plus the differences of the y's squared. 6 minus, well, that's easy. And 3 minus, well, that's easy. So this comes out to the square root of what? This comes out to square root of 45. So we don't need to use our calculator to find the decimal. We can see that's not the same. So we now know that none of them are the same. So what is the answer to the question? What is the answer? Alexandra? It's a scalene triangle. So we write down scalene. And again, spelling does count. Any questions about that? Okay, we actually had a second question that we were asked. Determine if the triangle is a right triangle. So now we need to figure out how to determine whether or not it's a right triangle. So we've got a kind of a part 2 or a part B. How are we going to figure out if it's a right triangle? You've got 1 minute. See if you and your teammates can figure out how to figure out if it's a right triangle. Go.
How do we find that?
All right. What'd you come up with? I came up with some crickets. Okay. Kamoy, what did you come up with your teammates? Okay. Interesting idea. What was that big word that you said? So if we can show that two sides are perpendicular to each other, then you've shown that it's a 90-degree angle, which then shows it's a right triangle. Let me help my students who are having trouble seeing it. What if we extended this side like this, and extended this side like that. You see it now? If we can show that these are perpendicular, or if we can show that those are perpendicular, then we've proven that that is a right angle and that it is a right triangle. But we want to be efficient about our work. Is there one part of the triangle that we could definitely say is not a right angle, so we don't have to test it? John, which one is definitely not?
One at the end, right side.
Okay, we'll use something that's there so we can all... Okay, so around here we can clearly see that that's not going to be a right angle. So that leaves us with figuring out either that or that. Which one do you think has a better shot of being a right angle? Stephanie? So we think O might be a right angle. So we have to show that these are perpendicular. How do we show that they're perpendicular to each other? Stephen? Slope. What about, how will we know?
P and PO has the negative reciprocal of the slope of OQ.
Very good. You said the magic phrase. The opposite reciprocal. So if we look at the slope of PO and look at the slope of OQ and compare them, if they're opposite reciprocals of each other, then we've shown that they're perpendicular. If they're perpendicular, they form a right angle. If it's a right angle, it's a right triangle. So that's the chain of logic that we need to follow. So let's go ahead and do it. So we need the slope of PO. Well, we've got a picture. How about we just use the picture? Rise 2 to the left 1. What's the slope of PO, of segment PO? Only 2 people can do that. I didn't tell you you had to copy the picture, but you could look up here and just do it. Sharif? -2. And what about the slope of OQ? So we need the slope of OQ. So we've got 2 points on the grid. So let's do rise. 1, 2, 3. Run. 1, 2, 3, 4, 5, 6. What does that come out to when we simplify that? Come on. Yeah. 1/2. And so now we need to compare this and this. Are those negative reciprocals of each other?
Yes.
Yeah, those are negative reciprocals, which proves that that is a 90-degree angle. And since that is a 90-degree angle, we have proven that this is a right triangle. So when you put it all together, you could say that this is a right scalene triangle. Any questions on how we did all that? Like I said, there's some grunt work involved. We went a little bit slower so that you guys could try and figure some things out yourself. Anyone have any questions? All right, let's see what you can do on your own. Checkpoint number 1. Triangle ABC has these vertices. Classify it by its sides and then tell me whether it's a right triangle. You got 3 minutes. got a number of people still working. It's all right. Take another moment to finish. It's fine. Alright, let's see how we did. Got number 6, 7, and 16. Number 6, what'd you get? Okay, number 7. Okay, what about whether or not it's a right triangle? Okay, and number, what was the last one? 16? Okay, this is a right isosceles triangle. So try not to think of it as getting it right or wrong. You know, give yourself half if you got part of it right. That's fine. We're part of the learning process. No need to beat yourself up over getting part wrong. How'd you do it? Because I didn't give you a picture this time. How'd you do it? John, what'd you do? Ah. Good. 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 Yeah, I think drawing a picture in this case was critical. Drawing the picture really shows you a lot. You know, kind of eliminates some work. Okay? Any comments, questions? So Stephanie, you said it was not a right triangle. Do you have evidence to support that it was not? What was your slopes that you got figured out? You made a mistake when you calculated the slope because it's actually 0 over -6, but there was another angle to test. So in this question, we knew that that wasn't going to be a right angle. There was no way. We thought this one would be the right angle, so we tested it. If it turned out not to be a right angle, then we should have tested this one. But we didn't need to because we found this was a right angle. If you didn't find one right angle, you should have tested the other angle to see if that was a right angle. Because one slope ends up being 1 and the other one is -1. Okay? Good. All right, so we're going to shift gears and use the theorems that we've learned. So example 2 has 2 parts. So this is part A of example 2. And we have this diagram, which you can sketch pretty quickly. And we're asked to find the measure of JKM. JKM. We are asked to find the measure of that angle. So this angle right here. But we don't have the measurement. We don't have this measurement. If we had this one, then we could easily find that one. All we have is what's given in this picture. So what could we do? I'll give you a hint. Look at your cheat sheet. Give me a thumbs up when you see which theorem we can use. Give me a thumbs up when you see the theorem that we can use. Got 3 people, 4 people. Is Several people who don't know the thumbs up system. 5 people, 6 people, 7 people. Kayla, what theorem do you think we can use?
The exterior.
Matthew, what theorem did you think we were going to use?
The exterior.
The exterior angle theorem. Yes, absolutely. I mean, look at the picture that's given to you on the cheat sheet. It's very similar to this. And what the theorem says is this angle will equal the sum of those two angles. And so we can set up an equation based on that theorem. X plus 70 is going to equal 2x minus 5. Solve the equation to find x. Make sure you know what we're being asked. But let's start with this. Find x. That's all mental math. You don't really need to do much. So what does x come out to? Just simple 2 steps that can be done mentally. Stephanie? Comes out to 75. Subtract x from both sides, add 5 to both sides, it's 75. So x is 75, so now we know that this is 75 degrees, but we also know that 75 can go in there, and that's what we were asked for, this angle right here. So 2 times 75 minus 5, what is the measure of angle JKM? What does it come out to, Nathaniel? 145 degrees. Any comments or questions on how we did that? So you got to know your theorems. Got to know how it works. I also told you that you were going to have to prove this theorem as part of your homework. Very important. But we'll get back to that later. All right, part B. Unfortunately, my picture didn't translate because I'm still having this projector issue, so let me add a couple things in so that you can see it more clearly. But of course, you're reading the text of the question. So this is a staircase. It was a little hard to tell, but this is a staircase going up, and then it turns and goes up again. The base of the staircase here, this is a tiled wall, but it's in the shape of a right triangle. This is the right angle right here. This is the right angle right there. Okay? Any questions about the setup? Any questions about the setup? Okay, so I think adding in my lines actually helps us because now we can look at it like that. And so now we need to take the information from the text and apply it and then somehow manipulate the information to get what we need. We're asked to find the 2 acute measures. Well, here's the right angle right here, so we already know that that's 90 degrees. But we don't know this and we don't know this. We don't know if they're the same or what, but we have some information in the question. It says the measure of one angle is twice the measure of the other. So what can we fill in for the 2 missing angles to help us? What can we fill in? Zumar? Very good. So x would be one of the angles, and then the 2x will be the other. Which one do you think is which? Where do you think the x should go, Zumar?
X on the top angle, the 2x
Okay, well, that's good. It's hard to tell. I would say it would be the other way around, but it's really not going to make that much of a difference. The drawing's not great. They actually look like they're pretty close in size, but I think they intended that to be x and that to be 2x, but it won't really make much of a difference because no matter what, we're going to get the same numbers. So it doesn't really matter. But now we need to set something up. So now I'd refer you back to your cheat sheet, and I would like you to figure out which theorem we are going to use to figure it out. Give me a thumbs up when you know which theorem we're going to use. Dayanara, which theorem do you think we're going to use? Okay, Alexandra, what were you going to say? You're both right, because we can do either one. If we use the triangle sum theorem, what will be on the left-hand side? Yeah? Very good. All of the angles will add up. 2x plus x plus 90 will equal 180. If we use Dayanara's idea of using the corollary, it will say this. What will be on the left-hand side? Kadir? 2x plus x. Is there any difference? Not really. Is one more efficient than the other? Probably. But will they both get you the same answer? Absolutely. So, we need to find the measure of the two angles. What are the measures of the two angles? We should be able to do it mentally, I'd say. Come on. And 30 is one of them, and the other one is? Very good. So this is going to be a 30-degree angle, and the other one is going to be a 60-degree angle. Very nice. Any comments or questions about that? So within two examples, we've actually shown that we can use three different theorems. Here we use the external angle theorem, and here we use the corollary to the triangle sum theorem or the triangle sum theorem. Anyone have any questions about either of those? All right, let's see how you do on your own. Checkpoint number 2, you got two different questions. Part A is based on this diagram, and part B is based on this diagram. Find me the answer to both. Make sure you read the questions carefully. Remember, you don't have to copy anything that you don't want to copy. You got 3 minutes. see how we did, start with part A. And I've got numbers 4, 6, and 11. Number 4, what'd you get? Number 4, what did you get? I'm sorry, just part A, you said what? 115. Number 6, what'd you get? I'm sorry? Okay, so we have a disagreement. Number 11. There is no number 11. Number 2.
65.
Okay, so we have a disagreement, and it comes out to 65. So Yamara, you found me the external angle. I asked for angle 1. Look at the diagram again. Part B. Part B, what did you get? We got number 2, number 7, number 2, 7, and 15. Number 2, what'd you get?
56 degrees.
Okay, number 7. 26 and what was yours?
56 and 22.
Okay, so we have a disagreement. Who was next? Number 15? Which was what? Comes out to 26 degrees and 64 degrees. What did you do in part B? What did you do? Anybody? What'd you do, Stephen? And then what allowed you to do that? Very good. That was a very easy, efficient way of doing it. So you end up with 3x minus 6 equals 90. Solve the equation, and then plug it in, and you get 26 and 64. Alexandra, did you find your mistake? Okay. Okay, I'll take a look. Anyone have any comments or questions on checkpoint number 2? Give me a thumbs up if you got both of them correct. Okay, so some of us are moving to mastery. Very good. Put your thumbs down. So, in the vein of the fact that this is geometry honors, let's take a look at this. Find the values of x and y. So, give me a thumbs up if you can see how to find x. Just focus on x, forget about y. Here, I'll make it easy for you. Let's take out the y for a moment. Let's get rid of this for a moment. How are we going to find x? Give me a thumbs up when you see it. Give me a thumbs up when you see it. Kalasia, what could we do to find x?
I think you could subtract 71
That would be great, except the 71 is only from here to here and is not including this here. So you're trying to use the fact that they're a linear pair, but they're not a linear pair. Okay? It was a good idea. Not going to work in this case. Okay? So what else could you do? Come on. Yeah, you've got 2 of the angles already. To find a third angle is easy. What theorem allows you to do that? The triangle sum theorem says that they all have to add up to 180. 90 and 40 is 130. So someone tell us, what is x? What is x going to be? What's x? Only 4 people can tell me what x is? Is that simple mental math? Matthew? It's 50. So we already know that x is 50. But I want to know what y is. And I've got this nasty y right there. So, you got 1 minute of team talk to see if you and your teammates can figure out how we can get the y. How can we get it? If you already have an idea, share it.
I would just explain. I would literally just I these things, whatever, like, subtract 50 and 70, add 50 and subtract that 50. And then that's whatever that is. And then that's fine.
All right, what'd you come up with? Anything at all? What'd you come up with? Team C's got some ideas. Team E's got some ideas. Team B's got some ideas. Steven, what'd you come up with?
Well, since I use x, okay, so x equals to 50, so we added 71 to 50, so I added that and I got 121, and then I subtract that from 180, and so the angle that's right next to 71 right there is equal to 59.
You're referring to this one right here?
Yeah,
Yep, I'll buy that.
so that's equal to 59, and then I added 59 to 55, and I got
Well, you don't have to tell us. I'm really looking for an overview, not the exact answer, but I follow your logic, and it's great logic. John, your team all had their hands up. What did you guys come up with? Okay. And someone else, Kadir, your team had come up with something? Same thing? Really? Same exact thing? So for those of you having trouble seeing it, what if we did that? And filled in what we know. 55 is right here. 2y is right here. What goes right here in my new picture? Stephen knows. What goes right there?
59.
No, right here.
120.
121, and you got that by adding the 71 and the 50 that is now there. So now I will buy that this is now 59, and then you can use the triangle sum theorem to figure out the rest. But what could you have done from this point instead that would have been even more efficient? Look at your cheat sheet if you need to. Zumara? Because of what? The exterior angle theorem says that this must be equal to the sum of those two. 2y plus 55 equals 121. Solve for y. So Stephen, you already did it your way. What did you get? Y equals 57? No, it doesn't come out to 50. Sorry, I'm sorry. Everything you had said up to that point was okay. You must have made an error in computation. Kamoy? Y comes out to 33, and then you were only asked to find x and y. You weren't asked for any particular angles, and so we've answered the question. Could you have done what the other group said? Of course. You could have figured out that that's 59, and then you could have said 2y plus 55 plus 59 equals 180 because of the triangle sum theorem. But now you're adding work for yourself instead of being thoughtful and picking the theorem that makes your life more efficient. Any questions or comments about that? Both are great. This is more efficient. Any questions? Okay, well, we did have a checkpoint that was really good, and I wanted to do it, but I'm running short on time, so we'll do this question at some point. I'll squeeze it in somewhere. It's a very good question. And I want you to also, of course, get more practice of finding two different values. But we're going to cut it short here. And so your homework is on page 211. You're going to do numbers 11 through 28, 32 to 37, and number 50. But I'm changing something. Instead of saying 28 questions, I'm now referring to it as points. I think this makes a little more sense because every question is going to be 1 point unless I tell you otherwise. So all of these questions are 1 point. All of these are 1 point. But number 50 is worth 4 points, and you are going to use the rubric that I gave you, and you're going to have to grade yourself. The proof, number 50, is you have to prove the external angles theorem. To do it well takes about 5 statements. There's more than one way to do it. Of course, you need to help yourself by doing the at-home tutor for lesson 4.2 or read the pages that go with the lesson. And we're going to have a quiz soon, but the schedule is really difficult to figure out right now, so I'll hold off and I'll let you know in a couple of days.